Hey guys, welcome to 212 day one. We're going to be talking about transformations of parabolas. All right, so this kind of sounds like a weird word, but transformations is simply talking about how do we move parabolas. All right, and that's what we're going to learn about today. So our first goal is to learn how to transform or move a parabola around on the graph. Right? So we want to understand how the graphing form relates to the graph of a parabola. So we talked about this graphing form yesterday and how to go from standard form to the graphing form. We also want to learn how to perform a stretch, horizontal shift, and vertical shift of a parabola. So we're gonna learn how to do those things today, and we're also going to learn how to reflect a parabola over the x-axis. All right. So let's take a look here. To learn how the graphing form relates to a graph, we need to understand what each part of the equation does to the graph. So you might be looking up here at our graphing form, and we have these pieces like we have an A, we have an H, we have a K, and we want to understand what those three things do to our parabola. We know what the X and the Y are because the X represents inputs and the Y represents our outputs of the function, but these A, H, and K things, we call these parameters, and we want to know what the effect of each of those parameters are here. So I came up with an example parabola that we see here. So we're going to work with this equation, and we can see our A value here is going to be 1, our H value is going to be -2 or -2, and then our K value is going to be this +3. All right, and we're gonna go experiment on a graph, and we're gonna change those values a little bit so that we can see what effect they're having on our parabola, and then we'll kind of write this in our table here as we figure that out. Okay, so I'm going to switch over to Desmos where I have this equation typed in already, so let's go take a look. We're going to experiment with the A value first, so we're going to be changing this thing around the 1, and we're going to see what that does to our graph. Okay, so here we go on Desmos here. We're looking at our equation that we had on our notes, and we're trying to figure out what does this 1 do to our parabola over here. And as I change the 1, Desmos will automatically change the parabola for us so that we can see the effect that it has. So let's say instead of putting a 1 there, let's say I put a 5. Let's see what happens. So I'm going to get rid of the 1, type a 5. And you can see over here, right, there's our parabola. That's our new parabola. Let me go back to a 1, right, and back to a 5. And you might be saying, oh, okay, I see what it's doing, right? So as I change that number between the 1 and the 5, you notice that the parabola gets a lot skinnier. Right? So this number, the A value that's in front of the parentheses, controls how skinny or how wide my parabola is. All right, so I notice that if I can put a 4 in there, it's a little less skinny. If I put an 8 in there, it gets real skinny. Right? If I go back to 1, it's back at its normal size. Okay, so if I wanted to make a parabola wider than what it originally started out as, I might try a number that's a little less than 1, like 0.5. You can see how my parabola got wider there. I can make it like a 0.1 and make it real wide. Right, so the smaller that number that I put in front of the parentheses, the wider the parabola gets. Now if I want to make it skinnier, I need a number like 6 or 9, right, if I want to make it skinnier. So we need a number above 1. So let's go back to our notes and let's jot some of this stuff down that we just saw in our graph. Okay, so this A value, okay, it controls how skinny or wide the parabola is. Okay, so when we make something skinny, we call that a vertical stretch. That is the official math term for that. So vertical stretch equals skinny. And then if I want to make it wide, we call that a vertical compression. Right, equals wide. All right. And if I want to make something skinny, right, if I want to do a vertical stretch, right, then we need the A. So we're going to say vertical stretch means that a has to be something bigger than 1. Right? So 2, 3, 4, 5, 6, all those numbers that we experimented with, anything bigger than 1 is going to stretch our graph. If we want to do a compression, and I'm going to abbreviate here, if I want to do a compression, then a has to be between 0 and 1. Okay? So it has to be like a decimal or a fraction, so like 0.2, 0.3, something like that is going to compress it and make the parabola wider. All right, so let's go back here. Let's now experiment with this h value, right? This is the number inside of the parentheses. So I'm going to go back to my Desmos graph, and I'm gonna mess with this number here to see what effect it has on the graph. Okay, so let's go back and let me change this back to a 1. That's what we originally had, and we're going to mess with this thing. Okay, so I'm going to change this to, I don't know, let's try a 5 again. So I'm going to go from -2 to -5, and I'm just going to go back and forth here. And you might be noticing, so there we are at 2, and then there we are at 5. And you'll notice the parabola did start here at 2, and then when I put a 5 in, it moved over to the right so that it's lined up with the 5 here, right? So the x-coordinate of our vertex changed from a 5, or from a 2 to a 5, so it moved it to the right. Well, if I put a 0 in there, does that mean that it'll line up on 0? Well, let's see. And it does. Okay, so I wonder if I wanted to move it in this direction, right, then I would need to put in like a -1 here. So if I change this to a plus and I put a 2 in there, right, so instead of subtracting 2, if I add 2, notice that it moves it to the left 2. And if I change this to a -2, it moves it to the right. Right, so there's +2, moved it to the left. There's -2, moved it to the right. Okay, so this value inside of the parentheses, if you're noticing what's happening here, this value inside the parentheses, the h value, controls how the parabola moves left or right. Okay, so let's go back and write that down, right? So this controls left-right movement. Right, controls left and right, and we call this a horizontal shift. And over here, I just kind of put a reminder, like if I wanted to move right, so if I wanted to move to the right, we would subtract 2, right? This equals right 2. And if I want to move to the left, I would do a +2. This would move the parabola left 2. And it's kind of weird because it's backwards. You would think if I want to go to the left that I would subtract 2, but it's backwards when we're inside of that parentheses. And that's a big mistake that students make a lot, is they forget that it's backwards from what they think it is. Okay, so that's why I'm writing this reminder down over here. All right, last one we're going to talk about is the k value, this number that's on the end. So notice we have a +3 here, so I'm going to go back to my Desmos graph. I'm going to mess around with this value and see what happens to my graph as I mess around with it. Okay, so here we go. So I'm at that +3. Let's change it to a +5 and see what happens. Yep, okay, so let's change it to 2, 3, 4, 5, 6, 7, and I can kind of see what's happening here. Okay. And in that k value, this number that's on the end, controls the vertical movement of our parabola. Okay. And if I put that at 0, it should be at y = 0, right? So notice that the y value of the vertex changes to a 0. Okay. So if I wanted to go down, instead of doing plus a number, I would do minus a number. So like -2 would move it down 2 units. And if I change this to a +2, it moves it up 2 units. All right, so let's go write some of that down. All right, so the k value controls up, down. And we call this a vertical shift. All right, so then if I want to do, so like from our example here, we have a +3, and a +3 equals up 3. right? If I did a minus 3, that would be down 3. And so this one moves the way that you think it would, right? So adding moves it up, subtracting moves it down, all right? Unlike the h value. All right, so I think we understand now what a, h, and k does to our parabola on the graph. So let's take a look. Now it says to reflect. So when we reflect something, that means we're flipping it over, and we're going to flip it over the x-axis. So I'm going to go back to Desmos here. Okay, so notice how my parabola opens upward right now. I want to figure out a way to flip it over so that it opens downwards like this. Okay, so I want it to go downwards. And the way you do that is you take this a value and you just put a negative on it. All right, so notice how I put that negative in there. Now I took it away and it's going up. So it's a positive 1, it's going up. Negative 1, it's going down. Positive 1 goes up. Negative 1 goes down. And it doesn't matter what value of a you have there. Okay, it could be a 2, 3, 4, doesn't matter. If you put a negative in front of it, it's going to go down. If you take the negative out of it, it's going to go back up. Okay, so the a value, the value of a in and of itself doesn't control the reflection. It's simply the negative that controls the reflection. Okay, so I'm going to go back here, and I'm going to write in how do I reflect. All right, we just put a negative in front of the a. That's all there is to reflecting. All right. Now, the next thing they want us to do is they want us to find the vertex. So remember when we put this in, we had minus 2 plus 3. I want you to see a connection here. Let me fix this and put this back to its original state here. So we had minus 2 plus 3. And notice the numbers here at h and k. So notice our 2 and our 3. And then when I come over here and I look at our vertex of the parabola, notice the coordinates are 2 and 3. Okay, now if I change this to a 5, right, so notice now we have a 2 and a 5, and we look at our vertex and we see 2 and 5. All right, so these two numbers, h and k, can tell us what the vertex are, or what the vertex is, right? So to find the vertex, all I have to do is look at h and k. So I know my vertex is going to have a 2 and a 3. So I'm going to say 2, comma, 3. The h value tells us what the x coordinate is going to be, and the k value tells us what the y coordinate is going to be. Now remember, if it's a minus 2, you'll have a positive 2 here for the x coordinate. If this were a plus 2, this would be a negative 2. All right, so remember it goes backwards. That's what we had discussed here. All right, so let's take a look at a few example problems that we might run into with this kind of content. All right, so one of the things I might ask you to do is just describe the transformations just by looking at the equation. Okay, so notice our a, right, there's our a value, there's our h value, and there's our k value. All right, so I might talk about the a value first, right? So the first thing I could tell you is that it was stretched by a factor of 4. Okay. And then according to the h value, since it's a minus 3, it went right 3. Okay, so it was stretched by a factor of 4, moved right 3, and then based on that k value on the end, it was moved up 2. Right? And that takes care of it all. Now I don't see a negative in front of here, so there's no reflection, but these would be the 3 transformations that occurred just by looking at the equation. I can tell what happened to that parabola very quickly when we're in that graphing form. Okay. Now let's say we want to go the other direction. So in this particular type of problem, I'm telling you what happened to the parabola, and I want you to write the equation. All right, so remember our equation is going to start with a y equals, and always start with this graphing form. I always just write this out like this, and then I plug in the a, h, and k value by reading the clues up here. So it says it was reflected. Okay, no problem. That means it needs a negative. It was shifted right 5 units. Okay, no problem. That means h would have to be a minus 5. So I'm going to make sure it says minus 5 inside of the parentheses. It was shifted up 8 units. Okay, so that means I'm going to change the k to an 8. And then it was a vertical compression by a factor of 0.3. Okay, so remember, compression means we're making the parabola wider, and that means the number has to be in between 0 and 1. So I just need to put a 0.3 here in front of the parentheses. That's all I have to do. That's my equation for this parabola that I'm describing here. Okay. The last type of problem we're going to talk about today is just simply finding the vertex, right? Can you locate the vertex of a parabola just by looking at the equation? And as it turns out, you can. We only need two values, the h and the k. Okay, so when I write my vertex, right, I'm going to have something that looks like this, and my x-coordinate is given to me by the h value. Since that's a -3, I'm going to put a +3 here, and since that's a +2, I'll put a +2. All right, so remember, the h is opposite, the k is the same. So this would be the vertex of this parabola. I don't need to graph it, I don't need to go to the table, I don't even need to see it. I know this is where the vertex is going to be. Alright guys, that's it for today's lesson. Give the practice problems a try. Good luck. Let me know if you have questions.